Hi there, I'm Terry. This is going to be one of those 5-minute velos that's much longer than 5 minutes. A few months ago I started to build a new bike, one bike that would hopefully meet all of my cycling needs. I purchased a relatively low-cost carbon fiber frame set and wheels direct from China. Over the last few months I've looked at various aspects of that frame set and wheels. I wanted to know, is it good enough quality and is it safe to ride? In this video, I'll look at the carbon fiber manufacturing quality of the frame set. In order to do this properly, I really need to apply advanced non-destructive techniques or cut the frame up. I don't have the equipment for the former, and I'm not going to cut the frame up. So I'll poke around through the various orifices in the frame. In my last video, I left you with this picture of the bottom bracket shell. When I first saw the picture, I thought, oh dear, I bought a Dove frame that's full of voids. It turned out to be overspray of the black paint and made it look like it was voids. In further examination, I couldn't see any voids in the bottom bracket bearing support areas. Looking deeper into the bottom bracket area at the junction with the chainstays, the carbon was very smooth and there was no resin pooling. What I could see was also unidirectional carbon fiber as advertised. In the bottom bracket area, I couldn't feel any steps, discontinuities or resin pooling. It was all very tidy, very clean and seemed to be compacted well. The inside edge of the bearing support area is a little ragged, but that's not unusual. In most frames, the front and rear triangles are bonded together. I couldn't access the bond area internally, but on the outside there was little sign of the join. Only when I caught the light at the right angle could you see a slight discontinuity. I didn't find anything of concern in the bottom bracket area. Indeed, what I could see looked pretty good. In the top of the head tube you can see the headset bearing seat. In an earlier video I showed the bearings fitted nicely into those seats. However, you can see areas where there appears to be a lack of material. This is not ideal, but at least the headset race is supported around the entire circumference. I don't expect that lack of material to cause any structural issues. Where the lower headset race fits, things look a lot better. Like the bottom bracket, the inner edges of the headset seat areas are a little ragged. But to be honest, I've seen this on higher end frames too. Again, I wouldn't expect it to cause any structural issues. At the bottom of the photo you can see what appears to be wrinkles. This is actually resin pooling and is a consequence of creasing of the internal pressure bladder that's used during manufacture. Excess resin from the pre-preg then creeps into these creases. Resin pooling is difficult to avoid, but in this frame the resin pooling seems to be more extensive in the head tube than I've seen in other frames, which contrasts with there being no resin pooling in the bottom bracket area. There are no signs that the carbon fiber layers have wrinkled, which would be bad. Looking down in the top of the head tube, we can see the junction with the down tube. There's a patch of woven fiber here, and at its top edge it looks as though it's not bonded, although I can assure you it is. That line is just one of those resin pooling areas, and there are some more resin pooling lines on that patch. But otherwise that junction looks quite clean. I looked inside the seat tube, but I struggled to work out how it was constructed, so I can't really comment on this. The photograph you're looking at, though, I think is a bit misleading. Visually, the fork blades look smooth, nothing showing through the paint, and I can't really add anything further. The steerer tube is the most important part, as there's no redundancy, and the consequence of its failure could be very serious. However, it's not painted, so I can get a good impression of the carbon quality. The steerer looks as though it's come straight out of the mold, with only split line flash cleaned up. In a previous video I showed that it was dimensionally good. I couldn't see any wrinkles in the carbon or feel any other discontinuities. The inside of the steerer looks smooth and well consolidated, although there are a few of those resin pooling wrinkles. I sanded and polished the top of the fork steerer in order to reveal its structure. It appears to be mainly unidirectional fibers. with a couple of layers where the fibres lay at an angle to the steerer axis in order to give it better torque, strength and stiffness. Near the surface there's a layer of fibres that run around the circumference. On the inside diameter there's a layer of what appears to be glass fibre composite. This is about 0.1 millimeter thick. It's not thick enough to have any significant structural effect, so maybe it's there to aid manufacture. The good news is I couldn't see any defects in that section, neither lack of bonding between the layers or voids. After the forks were moulded, the front brake cable guide tube was added and an additional layer of carbon fibre woven fabric. To be honest, I'd rather have the front brake cable external to the forks, so the steerer didn't have to have this hole in it. But it is what it is. I would have liked to have known whether the hole was moulded in or drilled through after. Moulding in is better, as the fibres can be continuous around the outside of the hole, whereas drilling it would cut those fibres. If it's the same as the hole at the lower end of the fork blade, it looks as though it was moulded in. The bonding of the cable guide looks messy, but as far as I can see, it's been glued in quite soundly. Visual inspection of the forks didn't raise any concerns for me. However, I must admit, simple visual inspection probably isn't the best way of evaluating these forks. So once the bike's assembled, I'll carry out some slow speed, very hard braking tests while listening out for unusual noises, and then inspect the forks again after for any signs of deterioration. I'll probably do this periodically for the first few months of use. The handlebar and stem are moulded as one piece, and access to the inside is poor, so I can't do very much apart from an external visual inspection. The surface is generally quite smooth, although on the underside there are a few small flaws, which are about 1 millimeter in diameter. These should not be a problem unless they're indicative of problems deeper in the carbon, which I can't tell from a visual inspection. The only area of bare carbon I can access is in the steerer tube hole. This has regions of woven cloth and unidirectional fibres. It looks to me as though it was moulded to near net size and then reamed out after moulding. I can't see any moulding defects, cracks or delamination, so it all looks fairly well consolidated. Because I've only been able to carry out a limited quality assessment, like the forks, prior to using them, I'll give them a high load test while listening for unusual noises, and then afterwards re-inspect the unit. I know I said at the outset I wasn't going to cut the bike up, but the seat pin is one area where I can get my saw out. Here I've cut the lower end of the seat pin off. I've cut it at an angle. I then sanded and polished that angled face in order to reveal the carbon structure. We're now looking down on that polished cut face. Let's start with the good. The section thickness is asymmetric. It's thicker at the rear of the seat pin than at the front. This is useful for two reasons. First of all, the clamping stresses will be most acute at the rear of the seat pin. Secondly, the rear of the seat pin will be subject to a compressive stress, and as carbon fibre composite is not as strong in compression as it is in tension, it makes sense to add extra material in those regions. This extra thickness is achieved by putting extra unidirectional fibres here. Indeed, the bulk of the fibres seem to be unidirectional and running down the length of the seat pin, which makes sense. However, there are some additional layers here and here that seem to be unidirectional fibres at an angle in order to resist any small levels of torque loading that could occur. That was the good. Now for the unexpected. On closer inspection under the microscope, the material on the inside of the red line shown here is actually glass fibre composite. Outside the red line, it's carbon fibre. The glass fibre is primarily unidirectional, with the strands running down the length of the seat pin. However, around part of the inside there's also a section of woven fabric. I'm not sure why that is there. Maybe it's for manufacturing purposes. My initial thoughts were, why have they put glass fibre in there? Are they just trying to cut costs, cut corners, cheapen it? It was time to get my calculator out. I carried out some basic stress calculations, assuming that the tube was round and of constant thickness, and that the glass fibre lining had not been installed. Here are those calculations. It turns out that even without the glass fibre, the seat pin is much stronger than it needs to be, at least 3.5 times stronger. So I thought, why add the glass fibre? After all, it's not as strong as carbon fibre, and it has a lower modulus. Of course, my simple calculations don't take into account things like the contact stresses or the stress concentration that occurs at the top of the seat tube. So in order to take these issues into account, I built a computer-based model that you can see here. So if we look at the maximum stress that occurs in the seat pin at the top of the seat tube, we're getting about 350 newtons per millimeter squared, which is lower than the assumed minimum strength of about 500 newtons per millimeter squared for the carbon fibre composite. So the seat pin, without the glass fibre layer on the inside, is still strong enough. So why put the glass fibre there? After all, it's just adding cost, not saving it. From an engineering perspective, I've rationalized it like this. Neither my calculations or my computer model considered buckling behavior. The most efficient way of increasing buckling resistance is to increase thickness where there are compressive stresses. The buckling resistance increases with the fourth power of the thickness, whereas it's only linearly dependent on the modulus. So from a buckling point of view, a thicker layer of low modulus material, like the glass fibre, is more beneficial than a thin layer of higher modulus material, like carbon fibre. So from this point of view, adding the glass fibre makes sense. So I've gone from thinking, oh no, it's got glass fibre in, to, oh, it's got glass fibre in. That makes sense. If this is the rationale, I'm impressed with Airwolf's design team. Any other engineers out there? Am I overthinking this? Am I over-rationalizing? Or do you have alternative suggestions? Now for the not so good. I'm now pointing out a number of lack of bond defects and voids. Mostly these are quite small, but they are quite numerous. As the seat pin should not be subjected to any significant interlaminar shear loading, these defects should not be a problem. However, it is worrying that they are there. I may need to keep an eye on this seat pin, and indeed, I may just buy a replacement. I have seen similar defects in another, much more expensive seat pin. Mind you, that one broke after I clamped it with too much force. I hope the consolidation in the seat pin is not indicative for the frame, forks and handlebars. First of all, I'll line up my excuses. This review of the quality of this frame set doesn't come close to the effort that I would have put in when I was a practicing mechanical engineer, which is why I've called it superficial. It was limited to visual inspection of the frame set parts, some analysis of the carbon structure, and I've also carried out some strength calculations. I suppose the bottom line here was I was looking for any indications that the frame may not be safe. Overall, no alarm bells rang for me. Indeed, I was quite pleased and surprised about the quality of the carbon layup, particularly given it's a budget frame. I didn't find anything that would suggest the frame is of substandard quality or would be unsafe. My only real area of concern is that seat post, but that's relatively cheap and easy to replace. The next step is to build it up. Right then, better get on with it. If you want to see with what and how I build the frame up, and if you haven't done so already, please subscribe. From me, for now, it's goodbye.